So for chapter 10, we have the convection heat transfer coefficient for a clothed person standing in moving air is expressed as 14.8 velocity to the 0.69 power for 0.15 less than the velocity less than 1.5 meter per second, where v is the air velocity. For a person with a body surface area of 1.7 meters squared and an average surface temperature of 29 degrees Celsius, determine the rate of heat loss from the person in windy air at 10 degrees Celsius by convection for air velocity. Velocities of A is equal to 0.5 meter per second and B for 2 meter per second. So what we need to find is the air velocities of 0.5 meter per second and 2 meter per second. First is we have given an equation of convection heat transfer coefficient, which is 14.8 velocity to the 0.69, and our equation for convection heat transfer is came from the Newton's law of cooling, which is the convection heat transfer times the area times the difference between the surface temperature and the infinity temperature. So for V, velocity is equal to 0.5 meter per second. We need just input the value into our equation. So our H is 14.8 and the velocity is 0.69 times the area, which is 1.7 meters squared, times to the difference between the surface temperature, which is 29 degrees Celsius, minus temperature infinity, which is 10 degrees Celsius. So we get an answer, 296.31 watts. For letter B, we have given the velocity of 2 meter per second. Just like the other one, we just need to put the value into our equation. So the same as H, which is 14.8, but the velocity now is 2 meter per second to the 0.69 times the 1.7 meter squared, which is our surface area, times to the difference between the surface temperature, 29 degrees Celsius, minus the infinity temperature, which is the 10 degrees Celsius. Now, we have the answer for this equation is 23.88 watts per meter cube, that degrees Celsius times 1.7 meter squared times 29 degrees Celsius minus 10 degrees Celsius, which is 19 degrees Celsius. So our answer for this 2 meter per second is 771.21 watts.